Good morning, everyone, or afternoon or evening, depending on where you are. My name is Julia, and I'm a development manager at SimCorp Product Development Unit. Today, I have a great pleasure of welcoming you all to the Software Engineering Day 1 here at SimCorp, and actually to our first keynote session, Lies, Damn Lies, and Metrics by Roy Ostrow. And I want to extend an especially warm welcome to all the many people who are joining us from outside SimCorp. We are super happy to be able to share that with you. What metrics can be used to drive the things we believe in? In this session, Roy will cover recommended and unrecommended metrics and how each one could drive our teams towards bleaker or brighter future. We had the pleasure to welcome Roy at the virtual stage last year when he was talking about the pipeline-driven organizations. And we are super happy that Roy could join us again this year so we can learn and get inspired by his keynote session. Roy works as independent consultant, training and consulting on all matters related to testing, engineering practices, technical leadership, continuous delivery, and pipeline-based organizations. Roy has over 20 years of experience in the industry and been in most types of technical and testing roles. And these days, he's working as a freelance consultant and trainer on site for various companies across the world. This session is being recorded. During the presentation, you are more than welcome to ask your questions in the chat function. And then when Roy finishes, I will facilitate Q&A session with you. And then with that, I hope you lean in. I hope you learn a lot today. And I will just turn it over to you, Roy.
Okay, everybody. Hear me? Not yet. Okay, good. Welcome everybody, and it's exciting to be here. Right here in the same room with oh no, wait, this COVID. So it's good to see everybody virtually and remotely. Hopefully everybody's fine and not suffering a lot of the bad stuff that's happening. You know, I think it's quite a difficult time. Keep repeating this. The past couple of years have been, I'm gonna say, it's driving me a little bit crazy as well. And I wish I could be there with everybody in person. Having said that, I want to talk a little bit about metrics and statistics because, well, actually, we've all been witnessing that when people are measuring metrics and statistics relating to COVID, etc. Suddenly metrics become very important, very interesting to see how progress is being made. And I want to apply the same thinking into the world of software. Now, the name of the talk came from a phrase that I heard that is attributed to multiple people. The phrase is there are three kinds of lies: lies, damn lies, and statistics. And nobody knows exactly who said it, but on Wikipedia, you can find all these people relating to this phrase. I'm going to go with Benjamin Disraeli specifically because I like the picture. I think that's the original kind of a, I don't know, thought-provoking picture. I like that picture. Anyway, let's move on to the next slide. So today we're going to talk about reasons why people use metrics. How do you choose the right metrics? Differences between leading and lagging indicators. It's really important to know the differences between those two. And specifically, I'm going to talk about metrics relating to continuous delivery. But you can apply the same thinking that I'm going to present today to any field that you're working on. We're also going to talk about anti-patterns and how those things, how we can actually abuse metrics. In fact, I bet that if I asked people if they know about metrics that are not useful being used in their organizations today, a lot of people would know about metrics that are not useful, or metrics that are actually can be very, very easily cheated and gained or presented to management simply to make them happy, but they're not actually helping the company. So we're going to talk about that. And the reason that I even got into this area is because I've been working in software for over 20 years, and I only understood the idea behind metrics and indicators only in the past few years as it really sunk in. But what makes sense? Why do we actually use some of these things? What should we measure so far, as far as I can tell? So this is still a work in progress for myself as well. We're always learning new things. Why do people use metrics? That's the big question. When I started this journey for myself, I asked, why do people even use metrics? When do they use them? In which situations? I'm talking about specifically for software. And I tried to put it in different categories. So here are different categories where I see people using metrics and indicators. So let's jump into these one by one. There is a category which I call planning and progress metrics, in which we use various types of metrics to measure progress, know what's going on, know what we've done, try to predict future performance, and looking at past issues. So if you're thinking about what type of metrics would fit something like that, stuff like burn down charts, you've seen them, right? So they're good for planning and progress, velocities, control charts, Kanban, work in progress board, all these things, they fit into that category. And that category is very, very important. And what you'll see is that there are, in many organizations, there are people that are specifically targeting those types of metrics. I think those are pretty common, or at least some of them are pretty common in many organizations. But even those are not as common as they should be. I've seen enough large organizations that might work in Scrum or something like that and not even have a burn down chart, something simple like that to know progress. You're not even talking about it. They're not talking about what does it mean for their organization. Second category is feedback. People want to measure their feedback. They want to see how fast their feedback is. This is specifically for the world of CI/CD, continuous integration and delivery. So you might test, you might measure things like how long does it take to run my test, and how long does it take to, how many unit tests have been passing, and a lot of these different types of metrics that some people might measure, some teams. And usually engineers might measure these things, and management might feel like these things are not important enough for them to look at. Then there is a whole category I call politics, which is when people use metrics specifically to either show management what they've done, convince management of what they want to do, or avoid management so they can let them work in peace. So for example, coverage sometimes fits that bill, unfortunately, where management wants to see code coverage, and so we show them code coverage. Does code coverage actually mean something for many engineers? Not necessarily. When I teach unit testing and TDD, I usually say that code coverage is meaningless because even if you have 100% code coverage, does that mean that your tests are good? The answer is no. But what we'll see later on in this talk is that code coverage falls into the idea of leading indicators. And leading indicators are a whole category of metrics that we can measure and we can even cheat on. But they're not the type of metrics that management would usually be interested in, which is the lagging indicator part. But you can use metrics to convince management, which is very powerful. For example, you can, if you wanted to get a budget for, let's say, a new build machine, you can measure how much it costs not to use that build machine, how many times people are waiting for build to finish, and then you can multiply that by the average hourly cost of a person. You have 100 people waiting for 5 minutes per build, which happens 3 times a day, right? That's 100 times 5 times 3. That's and then you can put a dollar value on it. And that's an example of something that management might be interested in. Another category is transformation. If we wanted to, and this is something that I am usually involved in as a consultant, I can use metrics to influence the behavior of people in the organization. If I wanted to change behavior, what usually happens is that if you start measuring a specific behavior, you'll either improve or increase or decrease it based on what you're measuring. So if I wanted to increase sparing time, I might start measuring that. If I wanted to increase coverage, I might start measuring that, right? Things that you measure have a tendency for people to actually focus on. What you see is usually, what you measure is what you get. If I wanted to decrease the time it takes to fix a build, I can start measuring those things. So metrics have a very powerful way of influencing our behavior. And people who understand this idea that what you measure influences people's behavior can be very, very effective in organizations. I would say that from all of these categories, understanding that when you measure people on specific things, you're influencing their behavior, whether you like it or not. Understanding that is, I would say, 80% of the job of management when we're trying to influence people without specifically micromanaging them. Decision making. So if I'm a manager and I want to do experiments, I want to try different things, different categories of work, different processes in my company, in my team, in my organization, I can start looking for various metrics that will tell me whether the experiment is successful. In fact, I wouldn't even try the experiment before I start measuring the baseline, which is what is the number before I start the experiment and how is that number changing over time while the experiment is happening. So if I'm testing test-driven development, the idea, I would measure something that it's supposed to make better. And here's a very interesting thing that happens. When people are trying to, let's say, invite me to do some engineering practices work or anything, the thing that I usually ask them is, what is the thing that you're trying to improve? When this is done, how do you know that it's successful? And if we don't have a good answer of what are we actually trying to improve, what number has to go up, what number has to go down, what percentage has to over time go up or down, something has to change. Otherwise, why are we even doing it? Then it means that we're not measuring something today that we should be. And that is a very, very powerful way to start a discussion and actually put it in, instead of a gut feeling, putting it in more explicit terms. So lead time, escape bugs, value delivered are examples of some of these things, but there are many, many more. My strategy, or the way that I use metrics as a consultant, is to use all of the things that are currently highlighted on the screen, right? I don't usually, I might look at burn down charts and stuff like that, but when I'm actively working as a consultant, I will employ metrics to help me in my consulting journey so that I can help influence behavior and I can help make decisions about what experiments to run with the organization, et cetera, et cetera. And then of course, I teach the organization how to use metrics when I'm not there. But the idea is to give them kind of training wheels to say, okay, what do we try? What do we measure? What's supposed to change when we try that stuff, etc. But I also use it when I encounter resistance. And this is a very common thing. And everyone who's trying to change something in any organization is going to counter some resistance. And a lot of times, when we try to understand why the resistance is even happening, why are people not wanting to do something that we're trying to change, you might find when you kind of try to investigate, you might see that some of the metrics that are currently being used by the organization are actively preventing you from changing that behavior. If people are measured on one thing, it's very hard for them to change it if the measurement doesn't change. And there's a sentence somewhere, I don't remember who said it or where I read it, but it's very hard to convince someone of something when their livelihood is based on them not believing in that something, right? So, and when we're measuring people in the organization, when we're doing metrics, we are effectively telling people that at least some or all of their livelihood depends on that thing being better or worse. That's why when we're measuring the wrong things, we can actually hurt the organization. And we'll talk about some of these anti-patterns. Now, the second problem that we have with metrics is that there are many of them. If I just do a quick Google search for software metrics, there's hundreds and possibly thousands of metrics to use. The big question is, which ones do we use for our team? I mean, look at this stuff. It's pretty impossible to what do we do with it? End user satisfaction, user stories carried on to the next iteration. I'm just looking through this stuff, right? They all seem okay. They all seem interesting. Do we measure all of them? And of course, the answer is not. And when I was looking at this, and I was looking for a way out of this mess of what do I do now, I came across this book, which is called How to Measure Anything. The book does not specifically talk about software. It talks about the idea of measuring things and how do you even approach the idea of measuring things. And what ended up happening is that the book was teaching me a very interesting lesson in why do you even want to measure something. And the big takeaway for me is you only measure things where you have a dilemma or where you have a decision that you would like to make. If you're measuring something without a decision or a question that's attached to it, it's going to be very, very weird or difficult or meaningless to continue measuring that thing. So when we measure something, we have to ask, why am I measuring that something? What's the point of it? What does it help me decide on? A dilemma is when you have multiple options to choose. So I'll give you an example of a dilemma, okay? And this is going to look very, very scary at the beginning. But imagine this, you're in an organization and your organization has objectives on the left, right? I want to increase quality and I want to increase speed and I want to teach skills to people in my organization. These are my objectives. They're not hard targets, they're just objectives. But my dilemmas on the right, they seem like they're pretty impossible to answer immediately, right? I want to increase quality and I want to increase speed and all that stuff. Well, I definitely know I need to automate a bunch of stuff, but which stuff do I actually need to automate? Which bottlenecks do I need to remove in my process to make things faster? What skills do I want people to learn? I definitely want them to learn skills, but what skills? What team structures do I use to make my process better? Because I want to do improvement. There are many. Should I use Spotify squads or do I use different things? What do I do? What type of process do I use? Do I use SAFe? Do I use Scrum? Do I use XP? Do I use a combination? Do I use Crystal? What do I use? These are dilemmas. And of course, there isn't one answer. The way about this is that we start by measuring things that we would like to change, and then we start doing experiments. And the results of the metrics will tell us what things we might need to automate, what things we might need to do to remove bottlenecks on. But I usually start by measuring two big things, and I call them lead time and cycle time. So lead time is specifically a time from the point where a feature in the organization is created in someone's head, or created in Jira for the first time, until that feature is deployed and running on a customer's machine or being used by a real customer, right? That time is called the lead time, which means that timeline takes everything into account inside the company. And the way to think about it is that we take a feature, right? That's the minion over there, and we put a GoPro, a camera on their head. And we say, I want you to tell me everything that happens to you from a time perspective and all the actions that are happening on you from the moment you're created until the moment you're deployed to production and running. And the time from that to the end, that's our lead time. Now, the lead time is an example of a very powerful metric, which is a lagging indicator, lead time. Lead time is very hard to mess with because it depends on hundreds and sometimes thousands of different factors inside the organization. But the lead time can also represent how competitive your company is in delivering something. And when we're talking about continuous delivery, lead time can also mean the speed of my organization. So remember that I said here, I have an objective of increasing speed. The lead time will tell me my current speed. So that's my lead time from here, from left to right. Then inside the different organization, inside the different handoffs inside the organization, you might see handoffs between different groups. Might be development, might be architecture, might be analysis. It might be just waiting in a backlog somewhere until the next quarterly plan is starting. All of these things can be represented as the idea of cycle time. Cycle time means that I have one part of the lead time and I have control over it. So development might have a cycle time because they control from the entry point into the developer's backlog until they are deploying to all the way to the environment where they have no control over. So if you don't have control over production, but you have control over staging, it might be from the moment you get the backlog item and you can start planning it until that moment that item is happening in the staging environment. It's easier to change cycle time because you have control over all the things. But when we're talking about bottlenecks, when we're talking about the differences and handoffs, you can start seeing that there are a lot of wait times between different handoffs. So you might be, so if I'm asking the feature, the minion, so how much of that time were people actually working on you specifically, and how much of that time were you just sitting there and waiting and nobody was doing anything? Because a lot of times we have multiple features sitting together in like a bucket, waiting to be tested, waiting to be developed, waiting to be designed, waiting to be estimated. There's a lot of waiting time involved. And those waiting times can represent an example of one type of bottleneck. Sometimes the bottleneck itself is that the fact that maybe design takes a long time or analysis takes a long time. But we can start with the simple stuff, which is the waiting time between tasks. And we can look at the waiting time and say, that's an example of a bottleneck, and we can maybe remove those bottlenecks and see which bottleneck is the biggest one, and then we can automate that or remove that. Or we can lower our work in progress, and instead of working on 1,000 items, we'll work on 100 or 10, and then the wait time for each item will be much, much faster. Or we can automate the fact that staging and testing takes a long time here. We might want to automate this stuff. So from lead time to cycle time to wait time, what we're actually doing here is we're discovering bottlenecks in the process of the organization. And those bottlenecks can give us a lot of information. And lead time is one of the 4 major leading indicators that I see being used in the world of continuous delivery. The others are mean time to recovery, escape bugs, and release frequency. And I'll talk about them specifically. They're all, what you'll see is that most of them are very easy to measure. How many escape bugs did you get from production last month? These are bugs that should have been found by our automated pipelines, but they were not found. How often do you release your product to production, to your customers? Well, once a month, once a quarter. That number is very easily gotten. Mean time to recovery is how long does it take from the point where my application fails or has a horrific problem in production until I recover from that problem on average. We are currently in the lead time. And what does that give us? Remember, lead time gives us the speed factor, right? So if I wanted to measure how well my objective is being reached, I can look at the lead time to see if it's actually increasing. Now, how do I actually increase it, right? I'm looking at the cycle times and the wait times, and these give me a lot of information on my dilemmas. For example, if I have to decide which things I want to automate, I'll usually look at the things that are taking the most cycle time. Which bottlenecks to remove, I'll usually look at the things that are either taking the longest or waiting the longest. So it gives me targets. If I wanted to learn what skills to teach people, I might realize that the skills that are missing are the skills maybe of automation, but which people should learn automation, or the skills of sharing information, or maybe the bottleneck is that I have back-end developers and front-end developers, but they cannot share the work. So maybe back-end will learn front-end or the other way around. Or maybe there's 3 people that know how the build works, and that's my big bottleneck. So the bottlenecks a lot of times represent skills, dependencies between teams, where the teams are waiting for one another, and that's where the wait times are. Team structures can help me decide how to teach those skills. They can help me decide on a lot of different things. For example, removing handoffs, removing bottlenecks, sharing information, and what type of process to use. Every time I experiment with a process, I can see whether it increases my speed or decreases my speed, right? Every time I try to teach skills or I try to change bottlenecks, I should be able to see it in the lead time, the cycle time, and the wait time to see if it actually changes something. And that's how I know it actually works or doesn't work. Escape bugs will tell me if I'm increasing quality, because that's where I see those things happening in production. If I see less bugs happening in production, it means that my quality or my pipelines are finding my bugs faster before I actually release to production. So I want to do the shift left kind of thing, where my bugs are being found faster than I can before they actually make it to production. And lastly, if I wanted to teach skills, we can use other metrics. For example, if I wanted to increase the skills in my organization and I wanted to measure it, I can measure the percentage of people that are cross-functional, or people that can do both back end and front end. I can literally measure that stuff over time and see if it increases or decreases. And the way that I measure it is that I keep asking teams, maybe the scrum masters or the team leads, and I do like every sprint, I'll measure that stuff and I'll do a quick survey. So those are examples of how metrics can use to answer some dilemmas. But what about all these metrics and all hundreds of others that we've talked about before, right? Code coverage and automated tests and unplanned work and build time, deploys. What about all these things? Do they matter or not matter? And of course they matter, but they matter in the discussion between leading and lagging indicators. So up until now, remember these 4, what are they? These 4. These are examples of lagging indicators. Mean time to recovery, lead time, escape bugs, and release frequency. Pretty much impossible to cheat, impossible to gain, because they depend on so many things. But by the time that you know them, it's already too late. It's already happened. Leading indicators are things that we are trying to change today, that we can change from day to day, that we have direct control of, in an attempt to change the future where the lagging indicators will change. For example, the easiest way I think about leading versus lagging is if I'm on a diet and I'm trying to lose weight. The perfect lagging indicator for a diet is the weight. If you measure yourself every week and you see your weight going up and down, that's impossible to cheat. It either goes up or down, right? And the way this works is, to be able to change your weight requires many different factors. You cannot easily cheat, and it takes time. So what are the leading indicators I can measure? Now, if I have an Apple Watch or I have like one of those wristbands, what do they measure? They measure leading indicators. How many steps did you take today? How many calories did you eat today, right? How much time of exercise, et cetera, et cetera. And my hope is that if my leading indicators keep going up or stay in a good place, eventually my lagging indicators will tell me that I've done a good job. But the leading indicators do not mean that I'm not cheating myself. In fact, I would argue that a lot of people going on a diet are doing a lot of leading indicators great, but they're still not losing weight because If you had measured other types of leading indicators, you would find out why. I'll give you an example. If I had a leading indicator of how many times the refrigerator door gets opened in the middle of the night, and I counted that as a leading indicator, I might see a very big correlation that it goes up and my weight goes up as well. So it could be that I have a lot of other stuff going on really nicely, like exercising and all that stuff. But if I still open my fridge in the middle of the night, my lagging indicator will not change. And that's the big problem with leading indicators. A lot of companies, they'll use the leading indicators as the goal, as the lagging indicator. They'll use it and they'll say, my goal is amount of calories per day. My goal is amount of exercise per day. My goal is code coverage, right? These are examples. So the things here on the left, branches, coverage, and unit test, and all these things, they're leading indicators that hopefully will impact the lagging indicators here. The eventual indicators, of course, are if the company is profitable or not, right? But these things are supposed to be connected almost directly to these things. But these things here on the left, branches, coverage, etc., a lot of companies are treating them as if they are the lagging indicators. And then what happens is that the company, all the indicators look great, but the company is struggling. They're having a big issue. And so when we treat leading versus lagging, we can come up with, we can lie to ourselves if we don't measure lagging indicators. That's where the anti-patterns come in. Here's a very good example of not leading versus lagging, but a wrong lagging indicator. Remember I told you that when you implement the wrong metrics, you might cause the wrong behavior. So a very common metric happening in organizations today is mean time between failures, MTBF. And a lot of people working in the IT crowd might have heard of it. If you're working on any environments like production and your job is to keep them up and running, this might be one of the metrics you're measured on. What does this actually measure? Mean time between failures measures how long the production stays green or stays up, right? So the longer it stays up, the better your life is as the person in charge of this stuff. What does that influence? If I'm measured on how long something stays up, it means that my incentive is to make sure that it's never down, okay? What is the best way to make sure that the production doesn't go down? The best way to make sure it doesn't go down is to make sure that it doesn't change. So I'm going to actively prevent changes into production because I measured on production going down or production staying up. And so my incentive is almost the opposite of what developers are being measured on. Developers are usually measured on changes. They're measured on how many features can you push into production. And so I have two pieces of the organization that are fighting with each other. One of them is actively trying to make the other not successful because they're measured on things that are actually fighting with each other. What if we change that metric? Instead of mean time between failures, we'll measure mean time to recovery. We're measuring the red stuff instead of the green stuff. We're measuring how long the red stays red. We're not saying that red is bad. We're saying that red that stays red is bad. What is my incentive in this case? If I measured not on how many reds I have, but how long a red stays red. My incentive now is to have quick recovery mechanisms, maybe feature toggles, maybe parallel environments, maybe easier deployments, maybe faster branching mechanisms, automated smoke test for production. I have a lot of incentives, but they're all now aligned to my development organization because now I'm no longer fighting changes. I'm fighting that a change that breaks production keeps production broken. And so I'm now allowing multiple changes because the recovery is the important part. So these are two examples of metrics that will change people's behavior. Here's another example of the wrong behavior. If your team, and this is more of a leading indicator, but it still changes behavior. If you've ever been part of a team where someone is telling you there are too many red builds versus time from red to green. Most teams measure the top, not the bottom one of these. But if I'm measuring the amount of red builds, What does that mean? It means that people are going to be afraid of having a red build. What is the best way to prevent a red build, a build that fails? The best way to prevent a failing build is not to merge your branch into the master branch. And now you're actually actively preventing code from reaching the master branch and going all the way to production. But if I measured how long it takes a red build to become green, which is almost like what we talked about before, we might get a different behavior from the team, which is the team is now focused on fixing pipelines. They're not focused on preventing red, because red is actually good for us. Red gives us feedback. It's like a compiler that tells us that the code is not compiling. We want to know that. We shouldn't be afraid of compiler errors. We should embrace them, right? We should just make sure that they don't stay there. So coverage, green builds, amount of tests, these are all types of leading indicators that people use as goals. Look at how many tests we have. Look at how many pipelines we have. What we want to do is to prevent that from happening by actually looking at lagging indicators instead of leading. Coverage, is coverage actually good? Not necessarily. Red builds, we talked about that, that's good, but coverage is suspect. Just because I have high code coverage doesn't mean that my code has high quality. So if I'm in a organization that measures code coverage, the first thing I'm going to look for is whether they're also measuring escape bugs or how many bugs are found in production. Because code coverage is a leading indicator that hopefully will change my escape bugs eventually. But if I'm not measuring escape bugs, then coverage becomes a very big problem because it's very easy to cheat. It's very easy to create the appearance that coverage is good, not by actually increasing quality. So we have a lot of vanity metrics today in organizations: coverage, amount of green builds, amount of tests. We should avoid them as soon as possible. And here's an example of a framework for metrics that I like to use, that I've kind of created for some organizations. And I think some people that have been on my training from SimCorp as well have seen this before. So when you're looking at creating a metrics framework, a measurement framework for your organization, what you're going to look for is going to have lagging indicators at the top. These are things that you really care about, and as a management and middle management are going to look at these things continuously. And this is just an example of continuous delivery, right? But you might have more of these. And then at the bottom, you'll have a bunch of leading indicators. And the leading indicators are going to be looked at. Of course, everyone's going to look at the top ones, but they cannot influence the top ones directly. They can only influence the bottom ones directly. So, for example, you might measure bottlenecks and feedback at the team level, how long a pull request stays open, right? Or how many people have specific skills, etc. And for each different teams or different layer in the organization, you look at different leading indicators, but the things on the bottom should be connected to the things at the top. And the things at the top, the things that you're trying to actually change, should be connected to your goals and to your objectives. So as a company, if I'm trying to increase my quality, then the measurement I'm going to look at is escape bugs. That's the one that I'm actually going to try to change, and I'm going to go down. I'm going to say, okay, which of these things do I want to change to increase this thing here at the top? And that's what we're going to look at in terms of metrics. Another metric that I highly recommend to use is confidence metrics. Confidence metrics is something that a lot of organizations do not use, but I highly recommend it. It's a survey that you will go through every couple of weeks, and you send to all your developers, and you ask them, how confident are you that the code in production does what it's supposed to do? And how confident are you that the tests that you have today are going to catch bugs? Confidence relies on a lot of different things, and every person knows different things about the code. Confidence, on average, doesn't have to be exact. It just has to go up or down. What you're going to look for in confidence is the combination of all the knowledge that people in your organization have, and will tell you whether your tests are actually meaningful or meaningless. And I've been to organizations where they have high code coverage, but low code confidence. So what does that mean? It means that we're lying to ourselves. We're writing really bad tests. And if you want to measure that you're actually lying to yourself, confidence metrics anonymously will tell you whether people are thinking that the code is, let's say, bullshit, or that the tests are bullshit. And I've been to organizations where they write horrible tests, but they don't. But everyone is so focused on just writing the test instead of focusing on writing good tests. So coverage should go up maybe, but your confidence on average should also go up. That's a very important thing. You don't measure confidence and you're not measuring production escape bugs, it's very likely that you might be lying to yourself. Because if you're putting this target in front of people's eyes, you're saying you're measured on coverage. Guess what? You're going to get coverage. Does not mean you're going to get good tests. Okay, a few recommendations, and then we're going to finish for today. Don't treat leading indicators as goals. Always pair leading indicators to lagging indicators. So there should always be a lagging indicator in somewhere in your metrics journey. When you're measuring lagging indicators, don't just measure one. Understand that they're actually connected to each other. For example, if you just measure speed, if you just measure, for example, lead time, you can increase your lead time on expense of quality. So lead time and quality usually fight with each other. There's a balance there. So you should measure lagging indicators that have a balance between them. And that way you're telling yourself, you're not lying to yourself as your organization. You might increase your speed at the expense of quality. Or the other way around. You can bring in 100 manual testers and decrease your speed. If you're not measuring your speed, you're not going to know. Don't measure things without a dilemma that drives them. So when you're measuring something, try to understand why are you measuring it. You're measuring it to influence something, or you're measuring it to make a decision about something. There has to be a decision about these things. That's it for today. There are some books that I recommend. One book that I highly recommend is, of course, How to Measure Anything. It's a hard read, but it will act as a good reference book. The other one on the left is The Principles of Product Development Flow. If you're familiar with Agile philosophy and development and all that stuff, this book is really good for you as an experienced person with Agile development, because it brings a lot of good thinking. And I've read it, and I was profoundly surprised by how many things I learned from that book that I didn't think about. It really explains things really, really nicely, and I highly recommend it. And of course, there's my books on the right. That's it. So we have, I think, maybe do we have time for one question? I think we have time, 1 minute for one question. So I'm going to turn off my my slides, and then we're going to jump into one question, and then we're going to finish for today.
Thank you, Roy, for yet another great session, and thank you all participants actually for being active in the chat. We have quite many questions, but if I dare just to ask one of them. So Roy, what's your take on the bias of metrics? That we have example like assuming that there is a false sense of security in front of uncertainty whenever a metric is present. In particular, there is a famous McNamara fallacy that subsumes such phenomena. So what would you say?
Oh, that's a big question. I'm not sure I can answer it by the time the next session. My recommendation is I'm going to take the list of questions. I'm going to maybe I'll put them on my blog as answers, or maybe I'll make a YouTube video about them. I just want to make sure people can go into the next session. So I thought it would be an easier question. Sorry about that. But I don't want to take people's time from it. So let me spend some more time with it. You'll send me all the questions, and I'll try to answer them separately. Okay?
Yes, that's
thank you very much, everybody.
Fine. Thank you.
Thank you.
And just to finish the session, so now this information is for internal participants. We will have 15 minutes break now. During the break, you can navigate the SWED portal and select the stream and breakout sessions that you are interested actually to join. And then we start again at 10:15 Central European time. And by the way, our feedback board is available at the portal. Please don't forget to leave your feedback after you attend any session during the day today. And as for external participants, we invite you all to join our next keynote session today at 1 p.m. Central European Time again by Linda Rising, which is called About Trees, Agility and Me. See you there.